Hello and welcome to Drawn Out Conversations, the show where I get to talk to other engineering leaders about how they've chosen to build their architectures to grow and scale. I'm Rob Zuber, CTO of CircleCI, and today I have a very exciting guest, Pat Shields, principal engineer also from CircleCI, and he's probably going to teach me something about our architecture that I don't know, and I can't wait. Thanks for joining me today, Pat.
Thanks for having me, Rob.
Why don't we start with something really straightforward that I think any CircleCI customer can understand, which is what happens when I, as a software developer, commit code and a build starts on CircleCI.
A pipeline starts on CircleCI.
Get a marker.
So we'll see how straightforward it is once we get into it. But if we imagine GitHub is somewhere out here in the cloud of the internet, GitHub's going to send us a webhook into CircleCI. Now, actually, we get a lot of different webhooks into our API. So when you create a pull request, when code gets pushed, etc., and we're filtering down all of those to figure out which ones we should trigger builds based off of. So our API does some basic transformation on this. We also support Bitbucket, for instance. So we have a couple different types of webhooks or people triggering through our API. Mm-hmm. And then we go ahead and put that into an intermediate format that goes into something we call our build service. And this is sort of our proper anti-corruption layer into the system. So what we're trying to do here is filter down into like a standardized format. So in comes something that's transformed mildly, but still is going to have GitHub specific information in it, like a GitHub ID. It's going to have maybe some specific commit information in it, and certainly tag or branch, the SHA, etc. Mm-hmm. And most of what we're doing in here is normalizing that into some standardized record that is really CircleCI specific. So at this point, we have what we call a pipeline. Now, a pipeline itself can decompose down into multiple workflows, but before we can even get to that, we do something called config compilation, and this is something that's a little bit new for us, where we've always had YAML, so ultimately this also includes a config that's YAML here. But it's been a pretty straightforward transformation, and I guess at the tail end of last year, we launched something called orbs. Mm-hmm. And orbs turned this problem from a, let's just load some YAML in, got a big dictionary, into something that was extensible.
So before you get there, where does the YAML come from?
That's a good point. So the YAML, for any CircleCI user who doesn't know, is in your GitHub repo. So you have a CircleCI .yaml file in there usually. And we're going to actually pull that from GitHub. So your webhook comes in, we do some basic transformation, and then by the time we're going to parse it, we've got to load it out of GitHub. Now, we don't actually clone your whole repo here. We just do a quick read of that file. Does that make sense?
Yep.
Hope so.
I knew the answer to that question.
I know, I figured. Okay. So build service is now going to take this YAML and actually send it over to something that we call our orb service, but I think it's actually a bit of a limited name for what this system does. So I'm going to say we're sending the YAML up here. And its actual job is to take that YAML and compile it into a structure that the rest of the system can execute. So I talked a little bit about this conversion down here, and a lot of this is metadata, right? We're figuring out which project it is inside CircleCI, et cetera. This is where we get the script for the work that the customer has to do. So in here, we'll do sort of an initial basic compile. And then we'll apply the orb transformations onto it. So if you're doing security scans, if you're adding some extra, hooks out to one of our partners, et cetera, all of that happens in here. And we wanted to get that all into a centralized service. So in the past, our YAML parsing, let's just say we've been a little bit loose with it and done it in multiple places. And that's always been a little bit problematic because we found like we'd upgrade a version of a YAML library in one place and not in the other, and there would be a slight gap or bug there. But now that we've added all this additional sophistication, it had to go into service, right? Where you weren't just loading some YAML library everywhere. Our orbs have to be able to apply their logic everywhere. And people are changing their orbs, they're updating, releasing new versions, etc.
So one of the things that's happening there is I have a reference to an orb.
Right.
And I need to include the fully expanded version of that. Is that correct?
Yeah.
And where is that coming from in that
So
context?
the orb itself, we do have something called our orb registry up here. And the first thing we're going to do is say, I've got twist lock, right? So we've got like a twist lock orb, and that'll be at some version, right? And the orb service is going to look that up in the orb registry, pull back effectively the recipe for the orb, and apply that as part of the config compilation. So what we get back from that is basically a structured representation of the workflows. Workflows. Back to our build service. Now, here's one interesting thing, and maybe interesting in an exciting and fun way. We actually create these workflows asynchronously. So what happens here is we register the creation of these. We say we're going to create a workflow, but that information gets put on a queue and then is eventually processed by something we call our conductor, our workflow conductor. So why do I point out that this is kind of interesting? We have been working on some new API endpoints that are in preview now. And one quirk of the system is that when you create a pipeline up here that has several workflows in it, it takes sometimes just 100 milliseconds or so, but it takes a minute for those workflows to show up. We've done that in the past because that kind of decoupling, asynchronous decoupling, has allowed us to be a little bit more reliable in the face of an individual service failure. But it has created this slight quirk of the system that's interesting, and I think we're learning something about the initial users of that API as it's in that public test. So anyways, the workflows do get created, and they go over to the workflow conductor. Now, the workflow conductor is basically the state machine of CircleCI, though that kind of oversimplifies it. So if a workflow is, most CircleCI users will be kind of familiar with this, but a workflow is effectively a series of jobs, some of which run in parallel, and then a network of dependencies between them. So we might say, this job needs to complete before this job, and then we can't do this final step without both of these. So a concrete example of that, for anyone who hasn't seen a CircleCI workflow that even gets up to a couple jobs like this, is you may have something like a security scan. And you may say, I want to run my tests, I want to do my basic build, I'm going to run the security scan in the background. And if my tests fail, I don't really care what happened here, but if this is my deploy step right here, I want to make sure I waited for my security scan to complete. So the workflow conductor is the piece of machinery that orchestrates all of this. So it's decomposing things down into jobs and then scheduling them out with the rest of the system. So from a service perspective, what that means is it's creating jobs and putting them on something called the usage queue.
And so when it puts a job on here, is it submitting all jobs, or it's ready at that point to know that these are jobs that can be run because their dependencies have been met?
Right. It's only going to submit the jobs that it can run at that time. So in this particular case, right out the gate, we can submit these two. Both these jobs have no dependencies. In fact, if you want to know a fun little quirk of the system that no one can see, internally we actually create a root no-op job so that we have a single entry point into the system. And we basically run that, which automatically completes. It's just sort of a different implementation of job, and then it kicks off these two.
Is that strictly for a reference management, some means to have a root?
Basically, yes. It makes it so that we have a way to get in to create to start traversing the tree with only a single entry point. But none of that actually shows up to you. It's just an internal quirk. And in fact, it never leaves the workflow conductor. So the jobs that come out here are actually things that we're going to execute.
Got it. Yep.
So we set them down in the usage queue, which is kind of a fascinating piece of machinery.
Can you explain what usage means in this context?
I can try. The way this is often described to engineers when they come to CircleCI is it's called the usage queue, and it's only kind of a queue, and it's only kind of about usage. So the name is both helpful and slightly misleading. So the usage here refers to basically usage of concurrency. So CircleCI now has moved towards a model where you're really paying for what you're using, as opposed to the old model, which is effectively a concurrency limit.
Mm-hmm.
And the usage was basically a counting semaphore. So you might have, say, 10x concurrency, and every time a job comes in, we subtract one, and then a job would come out and we do a +1. If you get down to 0, things stop flowing.
Right.
And that's kind of the first interesting part of this is it's not really one big queue. It's actually a per customer queue. So you have, say, customer 1 and customer 2. And while it's nominally in one big data structure, we've actually broken these down and we have a separate set of jobs.
Right.
So that's where it's only kind of a queue. It is a collection of queues.
Yeah.
Now, a couple interesting things. One is it's actually not even a per customer queue because we have multiple different, what we've historically called fleets. So one of the great things about CircleCI has been that it supports Macs. Oh, should I try to draw an apple? No, I'm just going to say we have two fleets. We have a Mac fleet, and we have what we've traditionally called our Linux fleet. So two different types of resources. And what we wanted to have happen was if you were a customer that used both, and so this was your Mac queue, and this was your Linux queue here, and for some reason, downstream in the data center, we ran out of capacity. A bunch of other customers are running things, and so you're starting to back up here, right? Your Mac jobs are filling slowly but surely. We wanted your Linux jobs to keep flowing through. Right? Now, if you want to get into the dirty details, Linux isn't quite as simple as it used to be.
Mm-hmm.
So this is something that we're working on right now, where we actually under here have Docker. So we have regular Docker jobs. We have our machine executors, and then we've slowly but surely started to add some specialized machine types.
Mm-hmm. Can you give an example of a specialized machine type?
Sure. So we have some GPU that a couple of customers are trying out. PyTorch is one of the more notable users of that. We've got specialized machines like GPUs, but let's do some real talk about our system. We've recently been working on adding Windows support, but I'm not going to write it up here with Mac and Linux. This is one of those interesting things as your system grows and you think about naming things, is that we wrote Mac and Linux because we had two different types of infrastructure that we ran customers work on. We had our Mac data center. We basically had the cloud, which we're relying on other cloud providers. And when we went to add Windows, we did not spin up a data center of Windows machines, which I think a whole lot of people in our platform group are really thankful for.
Yeah.
Instead, we relied on cloud providers. And so for the moment, this specialized resource type actually is under our Linux fleet, which suggests that we made an assumption when we wrote this that turned out not to hold.
That all cloud-provided instances would be Linux?
Yeah.
Yep.
So this is one of those case studies, and right now it's a small bit of overhead, but it's a bit of overhead. Every single engineer that we bring on, and we're bringing on a lot of them, we got to sit down and say, when you see Linux fleet, just so you know, translate that into cloud.
Yeah. Linux might mean Windows. That's an important thing to understand.
That's a business strategy conversation too, probably. So at this point right now in our system, we still only have these Mac and Linux queues per customer. But one of the things we're exploring is how to break this down even more, or at least find ways to make sure that if you're a customer that uses, say, GPU and Windows and Docker and Mac, that any sort of resource constraint or slowdown in any of those does not impact in the other ones.
And as you go to being a usage-based customer, meaning not even worrying about concurrency limits, does this continue to matter, or is that just about the resources that are available then versus the resources that you have purchased in these parallelism blocks, concurrency blocks?
Concurrency blocks. Parallelism is a different thing.
I know.
So it does still matter, and it matters in two forms. One, no resource is infinite, right? So even with our Docker fleet, right? Docker is the thing we can scale most easily. So under the covers, we're running Nomad. Maybe I should get a new sheet here. So
I'm just noticing that whole sheet of paper is probably about like 100 milliseconds worth of your job. Like the thing that started over here, all of this was before we even started doing anything. Anyway, sorry, keep going.
That's true. So, lost my train of thought. Cool. To make this example work, let me explain a little bit about how we run a Docker job.
Okay.
So we actually have a Nomad cluster, a huge Nomad cluster. Actually, now we have a bunch of Nomad clusters. So maybe I can make big boxes and say Nomad 1, Nomad 2. And we have a bunch, mostly for the reason we want to have a bunch of anything, which is every once in a while, something goes wrong, and we want to be able to shift traffic to the other one. And we are independently auto-scaling these, so there's many machines coming up or down or whatever supported on these. Most of this is running on AWS right now, so we have scaling groups and stuff like that. So, but it's still a finite resource.
Yep.
We can't instantly spin up everything to meet your demand. So there are a couple different ways that we think about that problem. One is, even if you're usage-based, we're going to give you some soft concurrency limit effectively. So I actually don't remember what it defaults to now, but you might say like 200x, right? So you can spin up to 200 Nomad jobs as a usage-based customer. That's still limiting for a lot of folks. And the unfortunate thing about it is that hard limit doesn't necessarily express the constraints of our system. It's just a number somebody made up. Why 200? Why not 199? So what we've been thinking about is something that we internally call task throttling. The task versus job distinction is some serious inside baseball, but the important idea here is to build a feedback mechanism. So if we have our Nomad clusters down here, I mean, and this would be true for all the instance types I talked about, and we're trying to feed work into them, rather than focusing on giving some hard limit to each customer, we can be looking at the health of this queue. You know, how full is it, right? We can be looking at how quickly we can add new capacity into that cluster, right? And make some judgment about what's available, and then this becomes more like a weight.
Right.
So if you're a really big customer, you know, we can increase that weight for not increase the wait time, it's a bad word, but we can increase the amount of capacity available to you just because we have it, we know we can bring it up.
How would that be different from prioritizing your work over others in that queue?
So I think it is a bit of prioritization in terms of there's probably still some, like here it's a fixed number, there it's more of a weighting factor, right? Like I have whatever 3.5 X allocated, whatever some baseline is. But the important thing is that it doesn't artificially constrain our customers. And then this turns our problem into a problem of how do we make our system scale faster. and meet that customer demand more quickly. And as we do that, every incremental improvement the customers are seeing, if we focus on having hard numbers like this, those results don't show up for the customers until they go back and get that number changed.
Got it. I wanted to call that out. You first called it soft and then hard. It's kind of softer in that we can adjust it on a customer by customer basis. Many customers never get to that limit, but many of our customers do.
Right.
And then we give them more room. But again, that's fixed regardless of what we manage to change in the system.
Yeah.
You mentioned one other thing in there, which is always fascinating to me, just getting systems online, getting hardware online, and the speed at which we can do that. I personally, having lived through days when we spent 45 minutes getting a box online, I'm curious kind of where that's at now and what kinds of things really matter in bringing hardware online to service this capacity as it scales up and down throughout the day.
Well, we don't have interns doing it anymore. So there's no people. No people are involved in the scaling of those machines. So that's important. Sorry, it's not that I'm against people. They're not good for this. Machines are really good for this. So auto scaling is both a solved problem and a huge complex topic. And there's everything. I mean, just to walk through it, right? If we have like a graph of time, and this is say Sunday at midnight. Let's imagine it's Pacific time. San Francisco is the center of the world, right? So, and then this is Saturday, 11:59. We have like a lot of places, a curve that looks kind of like this. Oh, I can't see the end of the line. And then drop.
Are these days getting shorter later in the week because you're just tired?
That's just my handwriting.
Okay.
That's the drawn together graphing style. So, I mean, right here, we can see that what we don't want to do is run our clusters like this. But to state an obvious point, we also don't want to run them like this. So there's the very basics of just like, how do we get ourselves to scale down on the weekends and all of that. But as you move towards a more sophisticated approach, where you're basically watching the shape of this demand, making some predictions about where it's going to go, or a lot of our systems still rely on a fixed overhead effectively. So as you have, if we were to like zoom in right here, and we have whole dashboards filling Datadog of this, where we have our actual demand, and then there's a dotted line above it, which is our overhead. So this space here is the amount of overhead we have available, or our slack capacity. And we're trying to keep that slack capacity constant. So getting back to your original question, which was what's it like trying to bring all those machines online? What do you run into? And the answer is, it's a huge problem. So at a lower scale, it's no big deal. And I would have thought, given a lot of my other experiences, that at a higher scale, it might even still not be a big deal, because if you have let's say if it takes 30 seconds to bring a machine online, but every once in a while you get an outlier, and that outlier is 3 minutes. But it all kind of averages out. Unfortunately, like most architectural problems, it's not random outliers. It's that a system that we're depending on fails. So traditionally for us, that's been an availability zone. So we'll be running in 3 AZs. And humming along, and then effectively AZ2 just is not in play anymore. It's taking so long to get machines from that. It's taking 5 minutes, 10 minutes, et cetera. And our ability to scale capacity suddenly drops out by a third. So instead of those little singular outliers, you lose large chunks of capacity quickly. We've actually just recently been improving this and allowing ourselves to push more traffic out to other AZs. So we now have some automated systems that can notice that AZ2 is going down and say, okay, let's spin up more capacity in AZ1 and 3, ride this out, knowing that most of the cloud providers will bring these back into play pretty quickly.
Yeah. So you referred to this as an outlier in a longer time, but then talked about this thing basically disappearing. Is there a threshold over which we would say those don't feel like good machines for us to be trying to get, even though it's not a hard, like this whole AZ is down and we're just going to start optimizing for the ones that are responding quickly? Or does it take the entire collapse of an availability zone, which is probably not super common?
No, we have an SLO that we put on the cloud providers, and we stop for per AZ, and we stop sending to that. I think that the team is also looking for unhealthy instances. So we have a certain set of expectations. It's almost like unit tests. So when a machine finally comes up, we're going to interrogate it a little bit and make sure it's in the state we think it is. So I don't actually know this checklist, but you can imagine things like, is it the image we asked for? Somebody told us about, or Mark, one of our more senior engineers, was talking about how we found a bug in Google Cloud because it was actually from their API. A bug in terms of their documentation, didn't mention it, but the metadata coming back from the API about the machine said the status was something like under repair. And it actually was fine. It's just something they haven't documented, but we rejected the machines because we looked at that along with the instance itself and we were like, this is not what we expected.
Right.
Perhaps it's not a good thing to run customer workloads on there. So we have that checklist, and I believe that if we find enough unhealthy machines, in addition to the kind of timing metrics I talked about, we'll also push it out to the other AZ. We'll assume that that's an issue with the AZ in particular.
Okay, so we managed to check to see if you have capacity in your concurrency plan and get a box online, or hundreds. Now what? Now what happens?
Once things come out of the usage queue, they go into a couple different services, the individual details of which don't matter too much, but the big things that we're doing at that point are basically preparing the definition of the job for the external system. So we were talking about Docker jobs, for instance. So we're preparing a Nomad task. We are going to take a bunch of job configuration and upload it to S3. We'll also do a couple things, like if you're using our secure context, this is the touch point for that. So we'll start to pull in some of your more secret data and inject that into the job config. And from there, ultimately, we're going to end up back in that Nomad cluster. Now, when that instance comes online, we're going to run a process in it called build agent. I'm just going to maybe it's BA here. And this is going to script the execution of your work. Build agent is itself communicating out to another system that is called the output processor. If I can squeeze it in. So the name here is another one that has probably shifted over time. There are a couple big things that this is responsible for. So it does what we call signal handling. So when your work, when the execution of your job completes, we'll do things like say, we'll send a signal that says, it exited abnormally with code 1 or whatever. This would just be like the exit code for the process. But the other thing we're doing is sending all your logs through here and your artifacts. And it's involved with things like workspaces and caches as well. It's the touch point between your workload as a CircleCI customer and the rest of our system.
And I'm going to highlight at least that this signal probably one of the places it goes. Oh, what a mess.
It's a workflow
Back here
conductor.
to the workflow conductor, so it knows that this job finished. I can do the next job.
Yes, but not exactly. So these signals here are just the internal signals between the build agent and the output processor. So it does trigger that, but there's some other fine-grained communication going on over here just so we can report the status. But the output processor will send, I can probably draw it on here. The output processor, I'll abbreviate it as OP, will eventually send a message to the workflow conductor that says job complete. And then the workflow conductor, going back to here, might check off another box and say, we can move to the next job.
Again. Cool.
And it's a bit of a diversion, but another interesting part of that, it's a bit of a diversion, but another interesting part of that is when the output processor is sending those signals, is receiving those signals and sending them out to the rest of the system. I mean, this is fundamentally an event, right? This is what an event architecture looks like. So there are many potential parties that are interested in this. And honestly, the way that we architected it inside, it doesn't work exactly like a traditional event system. And it's another opportunity for us as we grow out and want to be more extensible even internally. But we do other things here, like we might send notifications out to you. So when your job completes, for instance, we're going to want that to eventually be in your pull request over here in GitHub somewhere. So we might take that job complete and turn it into, if you're using GitHub checks, for instance, we'll update your checks and say your check run for that job is now completed successfully. So this is an idea we've done a little bit of, and it's something that internally our senior engineers and really the whole company talks about a lot, is working more off these event streams.
Right.
We've been so focused on this kind of command architecture, like we showed here, where some piece of work is flowing into the system and it's just going from spot to spot to spot to spot to spot, and we know everything knows about the parts around it, and then basically happiness, joy, and success pop out the top.
Right.
But as we think about becoming a more sophisticated product, as we think about how we can use our data to empower our customers, finding ways to inject these additional capabilities in without having to re-engineer and say, oh no, now we need to sub another box in here every single time. That's key to how we deliver things to the market faster.
I would imagine as well that that gives you an opportunity to do more for it, or create more opportunities for the customer to do more for themselves, right? Where I might be interested in changing the flow or responding in some way to the fact that we're partway through this process.
Totally. And so this is an internal event system, but your event system can go out to your customers too. So we have webhooks, and that's actually coming off here somewhere. But it's somewhere that we can add a lot more over time. The fidelity of the events we provide, a better subscription model, et cetera. Because what we're finding out is the course events that made a lot of sense for us a couple years ago, which is basically jobs running, jobs done, are not quite enough now. We want to be more reactive internally to even small status changes.
Right. Okay, so let's go back now to the output processor. Oh, right here, OP. And you also talked about logs, and I'm running a job, and I'm interested in the output, so I can look at that in my browser. I feel like streaming data in a browser is sort of a pretty common pattern these days. But what's happening behind the scenes to make that all work?
Sure. So the data is going to split out in two different ways. So one thing we want to do is get that log data into persistent storage, which for us means S3. So eventually, somewhere over in the cloud here, it goes to S3. In the meantime, we actually cache it in here. And from that cache, we're going to do that upload to S3, and we're also going to send out to something called Pusher, which is, it should be a cloud as well. It's out in the cloud. So this is just a slow accumulation of log data, and we're flushing it out. The flush is pretty quick for the Pusher data, but slower for S3 because we want to create a big enough record here. So we have our document over here of log data. Now, Pusher itself is going to send messages directly to the user's browser. And we do a mixture here. So sometimes we're sending live actual log data. So you're getting some blob in here that says like logs. And then I think it's an array. You're getting your text in here. But we also do some cache invalidation. So it depends on the page. You asked about logs, and logs, we're actually sending that data directly down. And then our JavaScript in the browser is going to then take that line and write it right in. But in other cases, we have pages like our workflow page, which is being altered by this same data. And for some consistency reasons, we're in CircleCI here, we're actually just sending a cache invalidation from Pusher. So we're going to say workflow 123 has been updated. And then the JavaScript in the browser is actually just going to reach back out to our API over here. Mm-hmm. The reason that we did that, I wasn't here for it, but if I were to guess the reason why we did that, you were here?
I was here.
So you can tell me, this will be fun actually then, because I'll take a guess and then you can tell me if I'm right. A lot of times when teams build these systems, they have the problem that the messages start arriving out of order, or they process them out of order, and then you have this nice sequence of like, workflow 123 succeeded, and then you get the workflow 123 failed message, and things go horribly, horribly wrong. So setting invalidations is usually a way to work around that, and you can bundle them up here so you're collecting them and then making the call and flushing it out. Is that why we actually did it?
No, but it's much more generous, I think. It sounds much smarter. It was purely a volume thing. We were sending out messages and unable to discern who all of the necessary subscribers were because of some early architecture with how we were using Pusher and stuff like that. And so we ended up overloading our fine partners over at Pusher in some of their early systems. And so we wanted to move a lot less data. And so we just sent a little notification and then caused you to come and fetch all of that data if your browser was open and you were having access to it.
So it was the payload size that you were overloading,
exactly.
not the number of messages.
Right, it was a payload thing.
Oh, okay.
Exactly. We were streaming out huge payloads for stuff that nobody really needed. And so we changed the way that it worked a little bit. But no, there are other places where we've had those exact consistency problems that you're describing. So you're not wrong to think that that is a problem that needs solving. This is just not. This is not one of them. As a great example, we have in the past run into scenarios where, I like that. I'm taking over for a second. Look out.
I've got some questions for you.
Here's where I pay the price for all of my past decisions. This is why you should sit on the left if you're right-handed. I'm going to turn a little bit. So you mentioned GitHub checks, but in earlier just GitHub, which I'll put over here for now, right? The build comes in, and this is like 1.0 time architecture, but I'm running a job, right? It's come in here, I'm doing some work, and then I'm sending it back out. Some older parts of our system are being updated. This is what our 1.0 architecture, this is 4 pages, the current architecture. This is how we used to draw the architecture.
Sure, yeah.
I lived in a simpler time. But we would update GitHub to say we're starting. So the whole life cycle of the build is, the build is pending, I believe is a check, or not a check, but a GitHub status. It is started or running. I forget which of those words is used on the GitHub side. And then it has completed and it's passed. Okay, or it's failed, but we'll call it completed passed. Looks like closed won, which is my favorite word that salespeople use. Closed won. It's 2 things, but it only means one thing. And if you send these 2 out of order, which we would, if we managed to run the build so fast that the piece of machinery that told you it was completed executed before the piece of machinery that told you it was started, then we would complete your build, or your build, yeah, over this is GitHub. You'd complete the build, and then we'd say, oh cool, we started it. And GitHub would change the status to started, and if it's started but not completed, then you can't merge your PR. But you were never gonna get a completed status because we already sent that one. It's interesting because in distributed systems you can solve these things in multiple different ways. There's no way that we could just send partial payload and have a check back because it wasn't our system. And it's possible that GitHub could say, wait, it can't possibly have started after it's completed, so we're not going to accept that. But there was no sort of state machine model about that. So we had to fix that in our system, clearly, to make sure that that transition of state could never happen out of order. It was a matter of, while I drew this very simple box, there was a piece over here, I'm trying to think, I think back when we were processing the usage queue or something that would queue the message to send out the start. But the complete would go as soon as it happened inside this job, so that might sit on the queue for a second. And in these really short jobs or builds, we would get out of order.
Even
This
in
is what
the
happens when you draw the old architecture. It's very simple.
Even in the GitHub checks example, we had to build a similar sort of thing to make sure that as we were getting in all this data, that we weren't making changes out of sequence. And the way that workflows have gotten more complex over time means that you might have a lot of jobs running concurrently. So we might get one update for a job, and another update for a different job, but we might be writing to the same endpoint.
Oh, yeah.
So you basically have like multiple interleaving streams, so that problem was the default for checks, and we had to work around it.
Right. Got it. Well, this is not only distributed systems within your platform, but when your platform is comprised of connections into other platforms, these problems are real.
So I want to do something a little different here, because I've had this question that I've been talking about with some of the other engineers for a while, but it's kind of coming to a head this week. So earlier, when we talked about the ingestion here, we've got this build service, and its responsibility right now is this anti-corruption layer from the perspective of taking all the GitHub specialtiness or the Bitbucket specialtiness out of it and creating something that the rest of our system can understand. But I think, and I was not here when you all started to design this, I think there's also this notion that this could be kind of an anti-corruption layer for the entire rest of the system on a whole other set of issues. So let me give you some examples. Today, I got a pull request to look at, and it was asking about defaulting of resource classes. So basically, like, if you don't say what kind of machine or Docker type, Docker size you want to run on, where do we decide what to run for you? Is that something that happens way down in the usage queue or beyond, or is that something that we solve up there? And that's just one example, but it's kind of, for me, that push and pull between how much do we centralize at the top, and then how much do we enable other parts of the system to act autonomously?
So I, as you know, really enjoy domain-driven design, aside from reading the books. And those are two core concepts that, as you're describing them, are in conflict with each other.
Hold on, do you want to switch seats?
Yeah, I'm gonna drive for a second. Okay, so I really like this question because I do think it's really interesting. And as you know, I'm a big fan of domain-driven design. And you're talking about a couple core concepts within domain-driven design, the anti-corruption layer, and then domain-driven design is the other part you're talking about, which is really domains sort of being isolated and having responsibility for their own capabilities. And these things coming into conflict because in this case, in order to effectively implement the anti-corruption layer with a little bit of nuance, which we'll get to in a second, we have to break down the domain isolation, right? So I'm going to draw the build service even though we're saying it is the anti-corruption layer. So I'm mixing metaphors here, but let's go with it for a second. So we receive config, I guess, right? And one of the things we used to do, which you alluded to previously, is parse the bits of YAML that we cared about where we cared about them, and then throw up error messages. And those error messages would be along the lines of, that's bad. Like no idea why it was bad or where we were in the YAML because we only got a little piece of it. And so there was an explicit decision in the creation of the build service to say, we have the whole file here, let's validate it. But in order to do that, you have to pull from somewhere down here, and I think this is what you were just talking about, the execution. Why did I make a box and draw outside of it? I don't know. I'll just call this execution layer, execution domain, right? Down where we make decisions about allocating machine types, that's where we know about the machine types, but in order to I'm using the validation example because I'm simple, but also in order to do the default assignment, I need to know up here what a reasonable concept of a default is, and I don't. All I know is YAML syntax at the super high level, right? In theory, I could if this is just translating. It's translating text into more text. And in order to have, but the YAML config can represent almost anything that can happen in our system, right? Is that a reasonable representation of, at least now we've recapped the question,
right?
And now I understand it.
But I think,
what should we do?
So, well, one thing that I think is interesting hearing you describe it.
Now you're going to try to draw from that side.
Sweet. So one thing that's interesting about the way you're talking about the question is, to me, you're talking about, you said validation. And I actually think, so that's part of it. So like throw up a useful error message, or I think honestly, one of the things that I've heard is, and we still have to do this in some places, we will create a job that fails.
Right.
We will literally create a job that just runs and prints out something. Because in certain cases, we're so deep into the system that just architecturally, it's challenging for us to communicate that back up so the user can see it.
Right.
So we'll shove it in a job output. So you'll open up your job and you'll see right where you would normally see your output some, hopefully now, helpful instructions about how to fix your problem. And then there's something here about, I'm going to call it conformance. I don't even know if that's a word, but you are taking that outside world and making it conform to the way you think about it.
Yeah.
But another interesting case here is we have something we call blocking. And this, I think, is where it starts to get more contentious, right? Everybody's looking at validation and they're like, cool, I don't want invalid stuff. That sounds bad. And conformance, generally speaking, is not a big deal. It does bring information from this domain up to here, but it's usually pretty straightforward. Blocking is where things get interesting. So
I'm just going to recap blocking as it's effectively preventing a piece of work from continuing that doesn't generally like fit into the plan, for example, of the customer that's requesting it.
Right. So it might be that they're asking for a resource class that they don't have access to. It might be that they've run out of credits if they're on a usage-based plan. And so we've talked about putting all the blocking up in here. And this is where the push-pull comes in for me. Because on one hand, it's super, it sounds really nice to say that once things get through here, we just have to run them.
Yeah.
You know, it's no secret, CircleCI has a lot of functional programmers. The idea that the rest of this is effectively just a nice pure function that just runs and then returns some std out and a couple artifacts, that's really appealing.
Yeah.
But on the flip side, it makes me nervous. Because the more complex that determination becomes, all of that lives here. And that's not really about validation. Now it knows all about how plans work, et cetera. There have been some ideas about how to do that where you basically shrink that. And this is going off and talking to like a plan service over here and just being like, I'll summarize this as is okay.
Right.
But we're slowly bleeding out a lot of things in here.
Yeah, I think we've been down both of these paths before, and I'm still always unsure about which one I prefer, right? Where more coordination gets pulled up into a single service. because I think the ideal is probably okay, right? Is okay, is this okay? Is this okay? Is this okay? But then in order to know how to ask the plan service if it's okay, either I have to give it all of my information and the plan service starts to have to understand our entire config just so it can find its piece, or I have to know the plans piece, which I know who all of my interconnected services are, and I've built this massive coordination layer. Then we want to change the plan service and we have to change the build service.
So that's the pickle.
Everyone builds for free. That's the answer to your question.
The future plan.
You heard it here first. What do you think? Where did you land?
Well, so the specific example that we had was basically if they haven't specified a resource, I think it was a resource type. It was a particular, it doesn't really matter too much. It was a YAML option, it was a YAML configuration that was optional. So it's optional config that's relevant to a very particular part of the system, in this case, what we call our execution domain, which, zooming back, is the thing that actually runs work.
Right.
And I made a bold assertion that at least one person agreed with, so I feel like I've been personally validated at the very least, which was if that optional config is basically subbed out for a particular fixed bit of config, and that's done on per version of the config, so we have like 2.0 config right now, we have 2.1 config.
Yeah.
So if you say in 2.0, when this option doesn't exist, it's just this particular string insertion. It's like a patch in. And we could talk about how internally we think about doing some versioning scheme here and working with customers so they know. But that basically, it's a fixed transformation on the YAML structure, and it's done based on the config. But on the other hand, if what we would ever be thinking about here is we want to roll out a new default type. We've found some new instance that's a little bit faster or a little more cost effective for us. And we want to roll that out to customers and see the impact of it. That to me has to go down here. Once you have this system responsible for the progressive rollout of features that are outside of its area, that sounds really scary to me. So in general, when I come to these, my default is to say push it down, which adds a certain amount of overhead. But when I think about a company that's growing like this company's growing, my fear is always that we centralize too much and then we don't give our developers internally the ability to grow what we are building. And just like you pointed out earlier, that extends outside too. Like we want to make sure that we are providing enough surface area in our APIs and in our webhooks that other people can build on top of us and create functionality that we've never even thought about. So there's overhead to that because maybe you make a check twice that you wanted to make once. But you gain that ability for this team to be more autonomous or the teams within this area to be more autonomous.
So the analogy that's in my head, because we've done something, we've had the same discussion about something else, is in authorization and the whole JWT model of basically, you know, in an API, right? Now I'm just, get rid of this for a second. You're coming in through the API and you're making a request, and part of that information is going to come from the execution domain, right? I might want to, nothing goes to our execution domain, but there was a box there. Part of it might come from plans, right? This is just information that you're serving up to a browser or whatever. And your models are basically, I can do all of my authentication up here. And then I build this really complex understanding of users and what they have access to and their privileges. And then to your sort of, all I want to do down here is run jobs. All I do down here is respond to these requests, right? Yes, you can have this information because I know in order to get inside the bigger box of our system, you've passed through something that understands your authority or your authorization and then your authentication. But you end up with half of this layer being about auth N, auth Z, right? And then you realize you need another system that does something different, like stream out logs or whatever. And now half of that system is auth N and auth Z, right? And so the JWT solution that I find really fascinating is to basically take this request. I don't have room to draw this. Somewhere over here, I'll use another color because that creates more space and makes it easier to find the things you're talking about. So somewhere over here, I've got an authentication service of some kind. And I say, hey, I've got this request from this user. Are they authorized? Yes, like they're actually, or sorry, are they authenticated? This is who the user is. Great. Give me a little bundle of what we know, and then I attach that, signed and encrypted and all those other great things, to the request, and it carries along with it. And then the plan system can say, oh, well, under those conditions, I will allow this user to get this data. But this service here doesn't really need to understand that package. It just needs to forward it on.
Right.
And so I'm trying to imagine the analogous approach here, which unfortunately feels like passing the entire config everywhere in the system, and the config is really big, and to be able to find it. But you can imagine a model where you get the config and you say, cool, I have a standard config parsing library or something that tells me what my little piece is, or I can say, where's this part found in the config or something. I mean, I don't have a great model for it because you just asked me this, but I wonder if there's an analogous model, because I totally agree with you. The thing where this becomes the orchestration of everything underneath and understands everything in the system, and every change everywhere gets replicated up into here, is not a fun organization or development model.
Right, and just to hammer this home, what I think is cool about the model you're describing is that you are still empowering these systems to make that authorization decision.
Right.
They're being given a standardized bit of information that allows them to do that, and it's also verified and all that for security reasons. So it's not that you're sucking up all those capabilities and those requirements. You're really just building an interface that the whole system can share to make those determinations.
Right, exactly. So that is a model that I like. So if I were trying to work this out, I would go think about maybe an analogous model, but I haven't thought of one in the 5 minutes we've been talking about it. Okay, so we talked about lots of things as they are today, lots of them historical and interesting. What's a problem that you're really excited about having the opportunity to solve here at CircleCI in the future?
I think we need to switch seats for this part.
Yeah.
So
Okay, good idea. Watch your head.
So, of all the things that motivate me, extensibility is the biggest one. So I think about it internally, but I also want to think more about it for our customers. So right now, we have a pretty thin API service, and honestly, a lot of what we think about is serving our UI. So we think about that user down in the browser and what's coming down the page for them. And we have some customers that are using our API to great effect, but I think we've limited what they can accomplish. And the other thing is we do have some webhooks going out to the customer. So inside all this machinery in here, we eventually send out webhooks. So this is our webhook service to the world. And these are effectively the touch points we need, right? But we need to increase the scope of them quite a bit. And I think one of the big challenges that companies have as they grow from being basically an application into being a platform is stopping putting features into their APIs and features into their webhooks and starting to think about the capabilities that they offer as an entire platform. Well, maybe that sounds really, really abstract, but when we build some of our API calls, we have things like recent builds, which is totally useful to build a very specific page in our UI. And it contains all the data you would need to build that page in our UI. But maybe that's not the page that every single customer needs. And so can we think about our approach to API design in such a way that it's a little bit more abstract and more capable? As an example, like there's no right answer to this, but I'm often a fan of classic resource-oriented design, right? So if I had a set of builds, I would have build 1, 2, 3, and that's going to be a standard payload back. And then I'm going to think about how would a user filter that down. So I might have some kind of filter syntax, etc. But when I'm doing this, so an example of a filter would be like, I'm looking for things that are state is done. Maybe we can do the URL escaping in post. So I'm looking for things that are done, for instance. But what's the difference between these two? Or like, I should say, I'm gonna order with completed at.
Mm-hmm.
So if that's the same as recent builds, and I think recent builds includes things that aren't done, what's the difference between these two? The difference here is this is a composable set of capabilities.
Right.
I can access a particular build, or I suppose this really should have been builds, but whatever. I can access a particular build, or I can access just a whole collection of builds and then filter them in different ways. And those filters themselves or other options are composable. So I can add a filter, and then I can add an order, and presumably there's some limit in what's coming back. Customers may have totally distinct special needs in what they want to see in like a dashboard, and we've had at least one customer, and I'm sure there are many more, that have built their own dashboard on top of our API. I think we can make that easier for them. So, and webhooks are another example where we're sending some basic data about like your job completed, etc. But I think we could give them a little bit more. So we could certainly be sending them things like when their job's completed, but we could also let them know that they've got a bunch of work queued, or we could let them know that maybe they've hit some threshold of failures or something like that, or their jobs are just taking a certain period of time or whatever. Basically increasing the number of events that we have going out here through this webhook system. And often, and this is a little bit hand wavy, thinking about those as being something that is actionable to the customer. So sometimes there's a tendency, particularly when you're thinking about from a UI perspective, to send that job complete event. And that's what matters because you want a state change in the UI. Yeah. But maybe that's too late for the customer to react if we have a more interactive system at some point, or if they're trying to script some work with their production environment in relation to what's going on inside CircleCI.
Yeah, I think one interesting example of that is to take a feature or an interesting way to come up with an example is to take a feature we've implemented. For example, auto canceling is an interesting feature that was highly requested for a long time, and then we eventually built for customers. And auto canceling is effectively if I have a job starting on a branch where I already have, let's call it a workflow. So I'm starting a workflow, I already have a workflow in flight, then I would cancel the original one because I know there's no value to that workflow now that I've updated the state of the system.
Right.
And it's great that we built that for customers, but you could imagine a world where I can figure that out as a customer and just say, oh, okay, now I can build my own capabilities around the edges of the platform. It's probably not the perfect example. You need to know a lot about what's happening in the system to do that right. But you could extend the capabilities in that way, but we wouldn't necessarily have the start state and the running state and the branch match and all that in the hooks in order to be able to get all that information and make a decision about it. So I think that one of the challenges, as you said, is that unless you stop thinking about the features, it's hard to realize, or it's hard to think about exposing more broad capabilities, right? And the recent builds is a great other example of that. This is what people want, so let's give them that feature, as opposed to we don't really know. I mean, people will come up with interesting ideas, and they won't be able to fulfill them with what we've given them.
And this isn't super technical, but the great thing about having an organization that's growing like ours is you have fresh eyes on this. And we also get a lot of feedback from our customers about the things they want. And the key for us as like a product and engineering group inside this rapidly growing company is to take that request, which often comes in as, I need recent builds too. I need the sequel to recent builds, and think, maybe there's more behind that. Maybe there's a particular need that this customer has, and another customer, and we can kind of find the larger ways they're thinking about the problem and then give them the tools.
Right. Cool. Very cool. I'm excited that you're excited about this because I think it'll be good for all of us.
I'm here to motivate you, Rob.
Thank you. I appreciate it. Cool. Well, thank you so much, Pat, for joining me here today. I always learn a ton talking to you, so I'm glad that we had a chance to kind of go through this and share with some folks. I really appreciate your fresh eyes on our architecture, and I'm happy that you dug into some areas that I was around for. Learned a lot as always. Thanks for taking the time, and thanks for joining us here on Drawn Out Conversations. We'll see you next time.